Using views. In this nugget, we begin a detailed consideration of what I consider to be one of the DBA's best friends, or most frequently used objects in a database. As we're going to learn, there are many good business reasons for using views in MySQL, or frankly for any RDBMS. Once we get that out of the way, we'll log into MySQL and create and test those views and make sure that the business reasons for creating them were sound. And then, of course, we'll use our metadata skills, our describe keyword, our create keyword, and we'll even go into the information schema tables in order to verify our views and obtain metadata about them. Let's get rockin' and rollin'. Why use views? Well, the preliminary question before we get into the whys are, what is a view and how does a view work? A view is defined as a stored select statement. So a view is an object that's created using the create statement, the DDL statement, just like we'd create a table, and it's stored persistently in the database, but instead of actually storing rows like a table does, a view simply stores a select statement. Therefore, views are often called virtual tables because they look like tables. Actually, in MySQL, we're going to see that views are stored along with tables in the table's namespace, which I find a little bit wonky and confusing. Most other RDBMSs will separate view objects and table objects. So in MySQL, it's definitely a best practice to add some sort of helpful keyword, like call your view v and then something else, or you could call the view whatever you want and then append view on it, because otherwise views and tables are, as I said, fairly indistinguishable in your table runs. Now, again, the virtual table means that the view is simply a stored select statement and doesn't actually contain rows like a real table does. Why would we use these virtual tables, these views? Well, there's plenty of really sound business reasons for doing so. As I said in the introduction to this nugget, I consider views to be a DBA's best friend because views allow us to take our base tables, which you'll remember are our fundamental storage containers for our data, and we can aggregate, we can mix and match, we can perform calculations on, we can do anything we need to do on that base data by using views. So views present an abstraction layer between our users and our base tables. Typically, best practice in database administration is we want our end users, whether they be business analysts or data entry operators or whatever, to be as far away from our base tables as possible, especially when it comes to simply presenting data. You should know and will work with updatable views, which are view objects that actually enable updates or changes to the data. And of course, since the view is in a sense like a filter, it makes sense that provided you build the view in such a way that it can be updated, that a user can go through that view filter and interact with base tables through the view. All right, so we understand that views are used to shield base tables from users, and we can display data in any format we want. Now, our base tables, you know as well as I do that if we've designed these properly, they're in third normal form, they're split out really granularly, but chances are, with database developers like us being what we are, the columns in those tables are probably not all that intuitively named, and if we let our users select against the base tables, they'd probably get confused within 2 minutes, right? So we can create views to, as I said before, use table joins to grab columns from multiple related tables. We can alias those columns and present the columns to the user in a much more user-friendly way. Another neat thing about views is that we can use functions to build calculations on that data. So we might have an employees table that has everybody's annual salary. We can build a view that does sums and averages and counts and so on that data and present the data as if it were a table to our applications and users, you see? Another reason, a third reason why DBAs and DB developers will use views is to preserve appearances of table structures. Over time, the bottom line is you're going to probably make some schema changes to one or more of your base tables. Now that could potentially break a lot of things. If you have stored procedures called stored routines in MySQL, and triggers and all sorts of other code that references the table and the table columns by a certain name, you don't want all of that stuff to break. It's kind of like a Rube Goldberg contraption or the game Mousetrap, if you remember that. Therefore, if you're using these views as intermediaries between your application and the base table, well, you can change your table schema as much as you want. You would simply run an alter view statement to modify or even not modify the view in order to maintain a solid schema for your applications and users. I hope that makes sense. Now, how do we create views in MySQL? Well, we do it pretty much the same way that we would a table, at least initially. And you'll see up on the top here, we've got some sample code that I've culled from the MySQL reference manual. What we're doing here is creating a table called T that includes two columns, quantity and price. And then we're using insert to put a row into that table named T. If we want to build a view that abstracts that table info and perhaps even add some additional functionality to the view, we can run create view and then the name of the view, and then as is the denote or the delimiter that tells MySQL, following the as keyword, expect a select statement that will actually define the meat and potatoes of the view. So in this example, we're saying we're creating a view named V, and the logic behind the view is this select statement. We're taking quantity and price, which were our two columns from the T table, and then here's where we get into some of the mathematics. Here we're just using straight arithmetic. We're not using a function. Here we're going to bring in a third column into our view that, as you'll see, doesn't even exist in the base table. We're taking quantity and multiplying it by price, aliasing the column name as value. I know that's a little bit confusing because we have as used to denote the view function, and we also have the as keyword in SQL being used to alias or rename a column. You see, if we didn't have this as value, then the third column here in our output would say quantity star price. And remember, the purpose of aliasing is to make these tables more distinct from each other and also to make them have a more user-friendly name. All right, so to sum up, we're taking two columns, we're doing a computation and creating a virtual column from the T-base table. And once we've run that statement, we have a view named V and a table named T. And then note that we can use views by selecting against them just as if we were selecting against a table. Therefore, select star from V returns the following row set. Quantity 3, price 50, which we inserted up here. And then our quantity times price virtual column, aliased as value, shows up as 150. Now, some notes to keep in mind. You cannot index views, no matter what. There's no, and actually what this means, I put no materialization, although you might think it's no matter what. And what that means is materialization means duplicating the data. In other words, the view is not actually going to contain all the rows that are reflected by quantity, price, and then a third row of data performing this computation. This is different behavior from, say, Microsoft SQL Server. In SQL Server, you can index a view, and when you do that, it does actually duplicate the data and store those rows in the view itself. Totally different here in MySQL. Another note that I don't have that I'll add, and I mentioned this earlier, is that views and tables share the same namespace. So therefore, when we get to the section of this nugget where I show you metadata retrieval, we'll need to go into the information schema database, into the tables table in that information schema database to figure out where our views are vis-a-vis what our tables are. But hopefully, as I've said earlier, we've used good nomenclature or naming conventions to differentiate our views from our tables. And then third, and this is again one of those wonky features of MySQL, you can drop a base table that's referenced by a view. Now what's that going to do to the view if, for instance, we nuke our T table? Well, it's going to break the view. So therefore you want to keep in mind, just keep a tight grasp on your table and view structure and ward against those kind of unfortunate events. Managing views. Well, as we've come to expect with data definition language or DDL statements, really there's just the three of them: create, alter, and drop. Once we've built a view using create view, We can certainly use alter view to manage or change the properties of a view, and then if we want to remove or drop the view, we can use drop view, just as simply as we can drop a database or a table or an index. Now, what is some of the appropriate syntax for the alter view command? The screenshot I've given you from the reference manual gives you the full syntax. The good news is we don't have to be worried with the security business because that's outside of the scope of the CMA, the MySQL Associate exam objectives. But what we do need to be concerned with is alter view, view name, and then you'll notice optionally there's a column list. And I'm going to show you how this works in the demo. But basically, if you're pretty standard, or might I even say overly standard with your column names, you might run into problems with views such that, let's say you had a table called A and a table called B, and you created a view that grabbed the name column from A and the name column from B. Well, that's going to create a collision, isn't it? Because unless we alias those column names, you're going to have a row set with a name column and a name column. So you need to keep in mind stuff like that when it comes to altering views. Therefore, you could say create view or alter view, and then in this case, in parentheses, you can pre-alias those column names. So you might call this first one name 1, and then comma, name 2. And that would serve to resolve this collision of column names. It's, again, one of those slightly wonky features of MySQL views that you should be aware of. The second feature, an optional parameter called check option, and this is important because what this does, if you add this option to your view definition, it prevents any updates to a view that would result in that row dropping from the view. All right? So let's say we had a view that grabbed everybody's salary from the employees table where their salary was above $50,000. And then because you had permissions set on the view so a certain user could make updates to the view, a user came in and changed somebody's salary from, let's say, $60,000 to $70,000. Well, that would be allowed, wouldn't it? Because the change, the update, would still result in that particular employee's record being returned in the view. However, if another data entry operator were to change somebody's salary who got demoted, let's say, from $60,000 to $40,000, if you have check option enabled in your view, well, that update would be rejected because making that change would have that row not show up in the view runs anymore when you do a select statement against the view. So know that this option exists, and if you do use check option, you can add optionally still either the cascaded or local keywords. These refer to the scoping of the check option command. Cascaded means that the check option is applied not just to the view, but to all other objects beneath it. Local will check the option only against the view itself. Now, as far as dropping a view, this is again, and I keep saying again, one of those wonky things with MySQL. You can drop the view. We have if exists that'll check to see if the object exists or not. View name, and then you've got this cascade keyword. And what this will do, it's kind of like the scoping option here, where cascade with check option will not only run the check against the existing views, but also any cascade views. And that's something I forgot to mention that I'm glad I thought of now, that you can actually link views in a hierarchical fashion. In other words, your view definition doesn't just have to pull columns from base tables. Your view can actually query other views. Kind of neat when you think about it. So that's what cascaded does with check option. There is a cascade option for drop view, but unfortunately, or fortunately, because you think it's could be a devastating option if it worked, the cascade option would not only drop the current view, but would also drop any views on which the first one references. And as the MySQL reference manual says, this option, this cascade option, is ignored the MySQL parser. Of course, my question is, why is it there if it's ignored? But such is the nature of open source software when you're dealing with a whole community of developers from all around the world. Obtaining view metadata. The best way to get data about data with our views is to query the information schema virtual database, and in particular, query the views table within that virtual database. But before we discuss that, let's just repeat one more time that views and tables share the same namespace. Therefore, you can run show tables in MySQL to get a run of your tables and views, and we can use the describe command to take a look at the schema or structure of a particular view. Those are well and good. We've been using those a while. What's new for us in this course so far is a detailed consideration of the information schema virtual database. Now, why do I call this a virtual database? Because information underscore schema, while it does have the hallmarks of a database, in other words, you can use it just like you can any other database in MySQL, and we can select against its tables by using the select statement. Information underscore schema is called an informational virtual database because there's actually no files. And that's a point that I should stress with views. Views are interesting and differentiated from tables because views actually do not create or use files in the data directory. All right? Now then, on a somewhat related tack, as I said, information underscore schema is called a virtual database because there's not a folder under your data dir for information schema, and you don't have any data files, you don't have any index files, you don't have anything. It's just a virtual database. In the information schema virtual database, you can run show tables and you get a list of 20 or so tables that define all the various objects in your database. In other words, there's a view in information schema called tables, which is very useful. There's an information schema table called views, which is what we're going to use in the demo, that can give us a list of just the views from a particular database. Now, I keep saying information schema views because in the information schema database, there are no tables. It's just a series of 20 or 25 read-only view objects, but it behaves just like any other database. Therefore, we can run a select star from information underscore schema dot views to pull all the rows from the views table. Now, of course, we don't want to see probably all the views from all of the databases on that instance of MySQL server. Therefore, we should use the where statement to filter our results. And this sample code shows us just the city view from the world database. And the terminology here, you just have to kind of do some internal translation. The table underscore name column in this views view, I keep sound like Dr. Seuss, right? The table name column in the information schema dot views view will store and allow you to return particular view names. I know it's confusing. It says table instead of view. And the other thing that I've referenced in other nuggets is whenever you see a reference to table schema or schema, do an internal translation for that to mean database. So we could look at all the views from just the world database by striking this comment and just saying where table underscore schema equals world. In our demonstration, we're going to build one or more views. We're going to work with that check option, and we'll also test the views. We'll work with updating views, and then we'll go into information schema and run some metadata queries to look at those views and check them out. In this demonstration, we're going to work with views in MySQL 5.x. We're on MySQL Nugget, that Windows Server 2008 box, and as you see, I've already logged into the MySQL client, and I've run a show databases command. All the examples we're using here have been adapted, or I adapted them from the mysql.com website. We're going to be using the world database here, so why don't we use world, and we'll show tables. World is a fairly simple database that has just 3 tables in it that definitely have relations among them through matching columns. So if we just wanted to build a view that took a couple columns from the city table, I guess the first thing we can do is let's run a select star from city, and then I'll introduce you to a new keyword, and that's limit. If you're not sure how many rows you're going to get back from a table, I mean, after all, In an enterprise MySQL database, a base table may have 1,000,000 or more rows, and you don't have the time or willingness to sit there and wait for the screen to update all those rows. You can just bring back X number of rows by using the limit keyword. So here, if I press enter, we'll select all the columns from the city table in the world database, just bringing back those top 10 rows. And you can customize the 10 that come back, or 100 or 1,000, whatever your limit statement is, by using the where clause. But here I decided not to do that. So we see that the city table in the world database IDs those cities and then brings in country code, which, I bet you dollars to donuts, those codes are stored in the country database. See the previous nugget we did where we talked a little bit about foreign key and related tables. Actually, we talked quite a bit about that, and you can see the benefit of creating this related column. We also have district and population. Now, if we just wanted to create a view that brought back, let's say, the ID and name columns, we can say create view, and then the name of the view, I'll say view city or vcity to denote the difference. Actually, I'll keep it all in lowercase. We'll call it vcity. As is our delimiter to specify the logic of the view statement. And in this case, we're going to say select ID and name from city. It's as simple as that. Now, if we want to add the with check option, we can do that as well. With check option. Just by specifying those words and then pressing the go button or the enter key on your keyboard. So now if we run a show tables, we have vcity showing up in line with the other tables. I've shown you the show create database and show create table commands. I wanted you to see here that you can run show create view against a view to get a list of the syntax that went into its creation. And as we've also come to expect, when you run a show create table or show create view, you not only see the text that you put into the definition, but any other defaults that were thrown in by MySQL are given in the definition. You see an algorithm statement, you see a definer statement that says that I as root user created this view, SQL security, and so on. So you see more than just what we have. And you'll notice here that with the check option enabled, the cascaded sub option is given by default. You'll remember that cascaded means that if I run an insert against this view, the check option will actually make sure that that update keeps the row in the view, not only for that view, but any related views that are referenced by the view. Well, I'm using view quite a bit, aren't I? Now, we can use the view just by running a straight old select statement against that view. Select star from vcity, and sure enough, we're getting lots and lots of rows back, just like I thought. One quick way to stop this is to use the Control-C keyboard combination. Control-C is the break character. It's been around in Microsoft operating systems forever, since the earliest days of MS-DOS. The Control-C key, I should say, also works on Linux systems. But anyway, the point's made. You can run select against views just like you can with tables. Another thing we could try is to create a view that pulls columns from more than one table. And to do this, we're going to use join syntax and create what's called an inner join. Now, I'm just blazing ahead gently using this join syntax that you're about to see. Keep in mind that we cover joins in an entirely separate nugget, so that by the time you finish this series, you'll understand everything, it is hoped, in a holistic way. So let's say we wanted to take columns from two tables here. We remember in our show tables statement that we have city, country, and country language. If we wanted to pull some columns from both city and country, I guess we can start by using the describe keyword to take a look at the rows in there. Looks like we've got an ID field, a name field, a country code field, a district field, and a population field. Looks like there's 5 columns in that. And let's do the same thing, describe country, and take a look at that. Again, we have code, name, continent, region. And as I've said before, there's a matching column here called name. It looks like in country, it's char 52. Let's come up to city. name is char35. As long as the data type's the same, that's all you need to create a matching row between those two tables. So you can see, I hope, where I'm going here. We have a column that's the very same name in both columns. So if we were creating a view, which we'll do right now, called v city country, and then in our as statement, we bring in a select. And even if we decided that, hey, although we want to see the name column in both of these tables, and we're probably not going to be able to say, for instance, select name, because that's too ambiguous. What if we qualified those columns with the names of their tables? Would that be enough? So if we said as select country.name to reference the name column in the country table, and city.name to reference the name column in the city table, shouldn't that be enough to differentiate? Well, let's specify our destination tables. Country and city are our destination tables. And let's filter this by throwing in a where clause. In fact, this is necessary to do joins, where code equals country code. So actually the join here isn't on name like I thought before. It looks like our join is actually between the code column and the country code column. So in the country table, we have code, and in the city table, we have country code. Well, that makes sense. So they're two columns that reference the same data, but they're named differently. And this, by the way, is the simplest way to create an inner join, where you just specify more than one table in your from statement, country and city. By the way, with an inner join, it doesn't matter whether we specify country first or city first. And then the where statement denotes the columns that are matching between those two tables that are going to be joined. And in this case, it's the code column and the country code column. All right, so let's see if this works. Nope, we got an error. It didn't like that and said that we have a duplicate column name called name. Even though we qualified those columns by prepending the name of the table, that still wasn't enough to differentiate them. Therefore, we're going to have to do this over again. V city country. And this time, as I said before, you can pre-alias those column names. So I'll call them CNAME, comma. Actually, that's not enough, isn't it? CNTRY name, and then I'll say city name. How's that? A little bit better. As, and then we can say select country name, city name. Qualification is still important here. From country, and just to prove that that doesn't make a difference, the order, I'll say city, comma, country, where code equals country code. All right, so let's analyze this second statement. So we're creating a view called vCityCountry. We're pre-aliasing those columns to make sure that they're separate and distinct, country name and city name, as select country.name, city.name from the two tables, and then our where statement defines the join, the matching columns. All right, so that turned out okay, no problem. Therefore, we can run a select from our vCityCountry view. In this case, I'm going to put in a limit of 10, just like before. And sure enough, now instead of just getting ID values, we actually can see the country name in full and the city name in full. That's another great benefit of joins. Otherwise, we would just have the country code and not the country ID. Now then, let's play around a little bit with updatable views in that check option. Let's run show tables again. And the first view we created was vCity, you'll remember. So if we run a describe vCity, this just tells us the columns that it's pulling. If we show create view vCity, this will give us the code behind the syntax. This is actually what I wanted to see, just to verify that we do have check option turned on for our vCity view. All right, so let's select star from vCity, limit 10. Well, if I can type correctly. There we are. And the question is, how about if we alter that view actually to put on some kind of constraint on which check option could work? So Actually, we're going to run alter view vCity, and we're going to redefine the select statement. We'll just say alter view vCity as select ID and name from city, but we'll say where name is like, we'll say A. See how that works? And we have to make sure when we're altering the view, if we still want check option to show up, we have to make sure to add that to our alter view statement. All right, good. So now if we select star from vCity, we're seeing how many rows come back? 259 rows. All of the countries, or the cities I should say, not countries, that start with A. That's all well and good. So the question is, what if we were to change, say, Amsterdam to something else? So if we were to say, update the vCity view and set the name column equals to Albany, where the name is Amsterdam. So we're actually functionally changing ID 5 from Amsterdam to Albany. Now, because I'm logged on as the root user, I have super user privileges, and I do have the update ability on this view. However, in the name of security, you'll want to make sure to only grant necessary privileges to your MySQL users to prevent something like this from happening, unless you actually want it to happen. All right, so if I run that select statement again, and I'll just say limit 5, we see that ID 5 is now Albany as opposed to Amsterdam. Now, the check option comes in if we decide to change the name. Let's say update vCity set name to Baldwinsville, where the name equals Albany. What do you think is going to happen now? You'll remember that the syntax, the actual code behind the view, only displays cities that begin with A. And we're now changing Albany to Baldwinsville. See? Check option failed world.vcity. So keep in mind how important that is. If we want to change the statement of the view to not include check option, we would just say alter view vCity as select ID name from city where, actually I don't even need the where, select ID name from city. That's fine. So now if I try to make my update again, update vCity set name equals to Baldwinsville, where name equals Albany, we should find that it does in fact work. Rows match 2, change 2. So we can select star from vCity where name equals Baldwinsville. And actually there must have been 2 references to Albany in that cities list, ID 5 and ID 4048, and those have been updated now to Baldwinsville. Before we go dropping these views, let's take a look at our metadata. I've showed you describe, I've shown you the show create view command. Let's show our databases, and we can, if we want to, use information schema. It'll make it a little bit easier because otherwise we would have to select information underscore schema dot whatever view we want to look at. So we might as well actually use the information schema database. And if we run show tables, we can get a list of all of the views that the information schema informational database contains. And sure enough, you see that we have a view called views. So if we just say select star from views, we can get a pretty ugly run of any views that are contained in this instance of MySQL. Why don't I run a \G to make this a little bit easier to notice? It looks like the only views we have across the entire instance are just the 2. Another way we can do this is to say select star from views where the table schema, in other words the database, equals world. A little bit easier to do it that way. Again, \G gives us a vertical display, and we see basically the same thing that we see with just doing a select splat. However, the where statement's nice because, as I said, it constrains our view list to just a single database. And the columns that come back in information schema give us the name of the database, called table schema, the name of the table, which is really, we know, the name of the view, and kind of confusing, a view definition, a nice succinct list of the definition of the view, whether we've got check option enabled, whether the view is updatable, who defined it, and so on and so forth. Client, connection, character set, all that good stuff. We'll do another show databases. We'll use world, show tables, and then as far as dropping these views is just as simple as drop view if exists, and then vcity. You can actually delete multiple objects at once if you want to, if you're into living dangerously, by just separating the objects with a comma. So drop view if exists, vcity, and vcity country means as soon as we press enter, those views are gone from the database. Using views review. In this nugget, I taught you what views are and why they're so important, not just in MySQL, but in any relational database management system. We also got into the meat and potatoes of creating and managing views in MySQL. I hope you're much more comfortable with that than you were prior to viewing this nugget. And then we finished by looking at view metadata, some of the built-in MySQL commands like describe and create. We also queried the information underscore schema views to gather some of that data about data. I hope that this has been informative for you, and I'd like to thank you very much for viewing.